any legal formula on the left, any legal formula on the right. Any complete sentence on the left, any complete sentence on the right. Can't have anything can't have anything unsaturated, can't have a propositional function on the left, no, nor on the right. But this is something complete, and this is another something complete. In fact, you have antecedent and consequent, the two ways in which you can, not interested, August? Maybe in a few years. All right, see you later. You have the two ways you can complete propositional functions to make sentences. This is the way of completing a propositional function to make a singular sentence. This is by annexing a propositional function, annexing the quantifier to a propositional function to make a sentence the other way. Okay. Something else very important about this. You'll have to learn to recognize that this is not a quantifier statement. Chapter 14 will teach you that there are two conditions for a statement to be a quantifier statement. First condition is that the statement start with a quantifier. This formula satisfies that condition. The second condition is that the scope of the quantifier goes all the way to the scope of the initial quantifier goes all the way to the end of the formula. Okay, as you see, the scope of the quantifier is going to be the first legal formula after the quantifier. So open brackets, I'll have my legal formula after I close that brackets. AX hook, I don't yet have a complete formula until now. Same as the scope of negation. If I was determining the scope of negation, if this was a negation, it would be this which is negated, right? The thing within the brackets. So what is the scope of this initial quantifier? This universal quantifier here is for all x. It's here, which means, right, that this is what's bound by the quantifier. This is the quantifier statement. So now its form is not a quantifier statement, but rather a conditional, right? You need to be able to see that in the order of construction of this formula, we made one of these, we had the singular sentence, we had this, we made this quantifier statement, and then in the last step of the construction, we combined that with that through that, right? We made a conditional, and this was its part. So this quantifier statement is a subformula of the conditional. That's different from, all Australians are surfers, right? All Australians are surfers. You've got a condition. You've also here you've got a universal quantifier and you've got a hook. Also a hook here. Here you've got a universal quantifier and a hook, but this is a universal statement, right? The hook is part of the propositional function which is bound by the quantifier, right? So in the order of construction of this, what happened? We made this propositional function, which is not complete in itself, and then last step in the order of construction is we annexed the quantifier to the propositional function, making it a quantifier statement, right? In this one, quantifier statement, we made it, we completed it, then we used it as a part of this. So this, right, we formed a conjunction. This is a subformula of the conjunction. Here, we did something different. We made a conditional propositional function, and last in the order of construction, we annexed a quantifier to it, making it a quantifier statement, okay? So here the quantifier statement is a subformula of the conjunction, not the case here, right? The scope of the quantifier is over the whole propositional function, including the whole propositional function that is itself a condition. All right, let's go on. How do I symbolize? This is a bit easier. I should have done this first, but Dan and Bruce are Australian. Okay. You've got a complex subject here. Remember them from translations in sentential logic. Complex subjects, complex predicates. You have to paraphrase them so that they can literally be. Right. This is complex because it logically contains two sentences as components. It logically contains it because it can be paraphrased such that it literally contains two sentences component, right? This is equivalent to Dan is Australian and Bruce is Australian, right? So how do you write this? Mistake, right? The wrong way. You don't write anything like this. This is not legal. A, say, D, B, right? No, right? The title of Unit 10 is monadic predicate logic. right? And we're doing monadic predicate logic from units 10 to 16, just when you have your third exam, the last one you have to take. After unit 16, for the Top Gun class, those who are going for the A, we do units 17 and 18, and we will do 2-place and 3-place predicate logic. Monadic predicate logic, what we're doing until unit 16, the rules of construction are propositional function, right, which stands for the predicate, and one place, right? The propositional function is just has one place for a name, right? One individual variable, the propositional function, to be replaced with one single name. It's not 2-place. When we do 2-place, right, so think of a predicate like loves, right? Dan loves August. You've got 2 names. You can make the you can abstract both of those names, replace them with variables, and you have the 2-place propositional function, x loves y. Right? That's exactly, that's going to, loves is going to be our paradigm 2-place predicate. Right? So when we get to unit 17 and 18, we'll see this, L 2-place, L, X, Y, which will allow all sorts of new fun things. You can replace one of these with an individual, right? So dy, Dan loves y, and then for all y, so Dan loves everybody, or if someone loves Dan, you can have, and you can also have 2 quantifiers here. Anyway, unit 17 and 18, that's what we'll be doing. Much of it we'll be doing lots of stuff like that. But we're already doing monadic, that is 1-place predicate logic, so no, you cannot symbolize this as A, B, A, D, B, that is not legal. So what do? Well, as I say, you think of this as, to be paraphrased as, Dan is Australian and Bruce is Australian. So monadic predicate logic, you're just thinking of your predicates as one place. They just predicate of single individuals, right? Or classes, right? When we get to categoricals, you'll be using these predicates of classes, but they're reduced to a set of predicates of individuals. Anyway, Dan and Bruce are Australian becomes, right, so you think, oh, it's equivalent to a conjunction. It is equivalent to Dan is Australian and Bruce is Australian, right? So it's just A, D, right? That is legal, that you can do. That's the correct way to make a singular sentence. And A, B, Bruce is Australian. All right, so it's conjunction, the major operator is the dot, right? If you had this as a formula and a proof, you could use simp, right? Again, simp, more or less the same as the rule of simplification that you've used so far, just the only difference is the elements combined in the conjunction, that is the simp, the rule of simp is premise, any conjunction, you're allowed to infer either conjunct. Simplification, right, here's just different elements. Singular sentences here instead of capital letters standing for particular sentences. So you've got the combination AD as opposed to just A and B or whatever. Different elements, but otherwise it's the same rule, okay? It's a conjunction, okay? It's a conjunction, you have to think of the rules governing this conjunction when we get to the proofs, which is what everything is tending towards, where we're heading. All right, Dan is Australian and happy. Dan and Bruce is Australian is a complex subject. Dan is Australian and happy is a complex predicate. Again, thinking back to sentential logic, analyses of sentences, translations. So again, we want to paraphrase this. Dan is Australian and happy is equivalent to, logically equivalent to, Dan is Australian and Dan is happy. And that gives us literally, literal analysis, that gives us the major operator. Dan is Australian and, what is it again?